Hi, I am Dr. T.V. Haimlakshmi. I am working as an associate professor in the Department of ECE in SRKR Engineering College. In this lecture, I would like to explain the error correction using a Hamming code. That is, how to detect and correct the error in the received binary data when the data is generated by using a 7-bit even parity Hamming code. Let me explain with an example. That is, find the error and correct the received data which is given below. The data is generated by using a 7-bit even parity Hamming code. This is the receiving data. That data is generated by using a 7-bit even parity Hamming code. Here, this data consists of 21 bits, but the data is generated by using a 7-bit even parity Hamming code. So, if you make this data into groups, that each group having 7 bits, then we can find the error. So in 21 bits there are 3 groups. We have divided 3 groups and each group having the 7 bits. In the first group, first 7 bits, next 7 bits in the second group, and last remaining 7 bits in the third group. In the first group, that is 7 bits, 1110 110. This is the 7-bit Hamming code that is generated and at the transmitter, and this data consists of data bits and parity bits, and these parity bits are added in the positions of 2 power n positions, that n equal to 0 1 2. When n equal to 0, that 2 power n equal to 1, n equal to 1, 2 power 1 equal to 2, when n equal to 2, 2 power 2 equal to 4. So the parity bits are added in the first position and second position and fourth position. These are the parity bits and the remaining are the data bits. From this data, we have to find whether there is any error or not. That error can be detected by using these binary check bits. Those are C3, C2, C1. These C3, C2, C1 can be found by using this formula, that is C1. That C1 consists of P1, D3, D5, D7. That is from the starting from the parity bit 1, first bit, and you have to take the alternative bits. That is you have to take first bit and you have to leave the second bit, and next you have to consider the third bit, that is the D3. You have to leave that fourth bit, then you have to consider the fifth bit, you have to leave the sixth bit, and then seventh bit. So that C1 can be found by considering this P1, D3, D5, D7. In this given data, that P1, D3, D5, D7 are 1, 1, 1, 0. In this data, this C1, in this code, there are 3 ones. That is an odd number. So, there is an error in the C1. Next, you have to find the C2. That C2, you have to take 2 bits. Starting from the parity bit, that is the second bit, you have to take the 2 bits and you have to leave the next 2 bits, that is P2, D3. You have to leave this P4, D5. After that, you have to consider the D6, D7. The next 2 bits, you have to consider the starting from the parity bit, second parity bit, that is P2, D3, 2 bits, and we left the D4, P4, D5. Next, you have considered D6, D7. Have to consider the 2 bits and leave them 2 bits. That is to find the C2. So P2, that is the 1, D3 1, D6, D7 1, 0. So that code word C2 equal to 1, 1, 1, 0. Here also odd number of ones. So there is an error in C2. Then we have to consider this C3. To find the C3, we have to consider starting from the parity bit, next parity bit. After the P2, the next parity bit is the P4, and we have to consider the 4 bits. 4 bits and we have to leave the next 4 bits. Here only 7 bits. So we consider the P4, D5, D6, D7. Those are 0, 1, 1, 0. Here even number of ones, so there is no error. Then we write C3 equal to 0. By this code word C3, C2, C1, we find the position of the error. That C3, C2, C1 equal to 0, 1, 1. That decimal equivalent of 0, 1, 1 is a 3. So the third bit is the error. In the given 7-bit code word, the third bit is the error. So we correct that bit. Here that bit is the 1. If we change this 1 as 0, then we get the corrected code word. That is the 11001110. In this code word, the message bits are 0110. That is the third bit 0110. Message bits are 0110. That is the correction in the first group of the bits. Next you have to consider the second group of the bits. Those are the 11001110. That's a Hamming code consists of these 7 bits. Here also you have to find that code word C3, C2, C1. The same procedure. C1 equal to P1, D3, D5, D7. In this data, that P1 is the 1, D3 0, D5 1, 0. The number of ones are 2. That is the one even number. So there is no error. That C1 equal to 0. Next you have to find the C2. That is the two parity bits. Starting from the second parity bits, you have to take the 2 bits and you have to leave the next 2 bits, and then you have to consider the next 2 bits. That is the P2, D3, D6, D7. Here the bits are 1, 0, 1, 0. Even number of ones are presented here, so there is no error in the C2. C3, that is P, starting from the third parity bit, that is the P4. We have to consider the 4 bits. Those are 0, 1, 1, 0. Here also even number of ones, so there is no error in the C3. That C3 equal to 0. C3, C2, C1, when you write this code word 0, 0, 0, hence no error in this 7-bit code word. So that receiving code is the correct data. So the message bits are, this is the D3, D5, D6, D7. Those are 0, 1, 1, 0. Next group of the bits are 0, 0, 1, 1, 0, 1, 1. You have to find the error in these bits also. The same procedure, that is the C3, C2, C1. C1 equal to P1, D3, D5, D7. P1 0, 1, 0, 1. Even number of ones are presented in C1, so C1 equal to 0. Next C2, starting from the second parity bit, you have to consider 2 bits and you have to leave the next 2 bits. Then you have to consider the next 2 bits, that is P2, D3, D6, D7. Those are 0, 1, 1, 1. Odd number of ones are presented here, so the error in the C2. Error, you have to write C2 equal to 1. Next C3, that is starting from the third parity bit, that is P4, D5, D6, D7, 1, 0, 1, 1, 1, 0, 1, 1. Here odd number of ones are presented, so that C3 equal to 1. Here that code word C3, C2, C1 equal to 110. So the decimal equivalent of 110 equal to 6. Hence the 6th bit is error in this 7-bit code word 00110111. Here the 6th bit is the 1. So we have to make this one as 0. Then we get the corrected code word and the message bits are 1001. In this procedure, with this procedure, we have to find this error bits in this received data. Here in this data, third bit is the error. Here there is no error, and in this group of data, sixth bit is the error, and these are the corrected data, and you have to write the message bits. If you observe these bits, this group consists of the 4 ones, and this group also consists of 4 ones. Here there is no error, and there is an error in this group of bits. So we should not say by simply by observing the number of ones in that code word. Even that number of ones are the even number, there may be an error. If you write in examination that received data, error bits positions and corrected data, message bits clearly, that you will get the full marks. All the best. Wish you good luck.